Let's talk about the Krebs cycle. Uh, Basically, why do students find it bit difficult? Though it's not difficult, but a little bit. There are more steps. So I will try my level best to make it more simple. Let's start from the beginning. But basically, when we go to the glycolysis, so there is a very little difference here. At times, the students basically they a little bit confused with glycolysis and the Krebs cycle. Actually, glycolysis takes place in the cytoplasm, but the Krebs cycle engine is in the mitochondria. So let's talk about the glycolysis. Why there is a need of glycolysis. So what happens in the glycolysis? So that is a very simple point that glucose, if we look at the glucose molecule, that is a very complex molecule, C6H12O6. So it means there are too much energy is packed in that, and uh, lots of electrons are interlocked in the glucose molecule. Well, but this glucose molecule cannot enter in the Krebs cycle engine, that I mean the mitochondria. Why this is so? Because this glucose molecule is bigger. So in the process of glycolysis that you have seen in your textbooks, there is a long multi-step process. Basically, the trimming of the glucose molecule takes place, and step by step. So you are well aware that right from the beginning, from the C6, it changes into pyruvate. So now you see the number of the carbons become half. So it means the trimming, so the trimming takes place. So now it's easy, now it's more easy for that molecule, the pyruvate, okay, it can go into the engine. Right now it's ready to burn in the engine. So now again let's talk glycolysis. Why there is a need of trimming, basically? As I said, number one, the glucose molecule is bigger, it has to be trimmed, and a little bit trimming, and then it is ready. It is ready in the furnace of the Krebs cycle. So, but one more thing that is really very important here. That is, so this pyruvate actually this combines with another molecule that is called acetyl coenzyme A. So this acetyl coenzyme A is formed with the combination of this pyruvate. So in some textbooks, people have mentioned it. That there is another reaction. Basically, they have just made it into a category that is called the link reaction, right? So we started from glycolysis and then link reaction. Now this is the time, this tiny acetyl coenzyme A. You can see that you are having some furnace. You are having some furnace, and then you are making the bigger coals into smaller coals, right? And now it's better to put the coals into that furnace, and they will burn more efficiently as compared to that one. So this is the point I want to basically make your point clear. Same as the case you can see in your cars. The petrol we use, the gasoline. In some countries, it is called gasoline. So this petrol is first. Goes into carburetor. Basically, it becomes fumes. So it's fumes because it's more efficiently burns. The fume burns more efficiently and little quantity as compared to the liquid petrol. So same is the case. Glycolysis, trimming takes place, link reaction, and then it enters into the mitochondrion. And here in the mitochondrion, the Krebs cycle engine is there. This is the most you can see the efficient engine for which Sir Hans Krebs basically explained that when you dive in deeper, and then you can find a wonderful world of natural processes taking place. Yeah. So this is the hallmark that how we can step by step go into the natural processes, and we can see not directly but indirectly that what is taking place, how the glucose molecule, it came and then it was trimmed and then it was added by another acetyl part, and then it entered into the Krebs cycle. So now the question is, most of the students very basically they do ask that what is something special with the Krebs cycle, that why it is a multi-step process. Of course, starting with acetyl enzyme and then citric acid, and you will be amazed that at times this is also called citric acid cycle. That some scientists they like to term this citric acid cycle because the citric acid is also produced in this. So in the one turn, the last in the last stage, oxaloacetate is reformed, and then it again becomes part of that other next cycle. So this cycle keeps going. Okay, now let's back to our main question, that what happens in this. Yes, number one, the electrons which are interlocked again in the smaller molecule, or rather glucose molecule, smaller in the smaller molecule, acetyl enzyme. Again, these are basically broken, or they get out from the interlocking system. So at this point, now you must be thinking, it looks very amazing that if the electrons are basically electrons get free, so where do they go? Yes, there is a system. Yes, there are electron acceptors. There are certain molecules which are accepting. There are NADs, NAD. Though the little bit term is a bit complex, nicotine amide adenine dinucleotide. So basically it accepts the electron. All right, so it accepts electron, and then they move further into the further that we will discuss later on. Formed